Hi, welcome to CCTV. I'm Philip. In 2019, I was asked to design a workshop for Neuztec, an ambient and experimental music festival here in Victoria, BC. I designed QuadTech 101, a Eurorack and battery-powered quad panning oscillator. The workshop was a huge success, and I began designing Shadowbox for Neuztec 2020. The idea of Shadowbox was to harness the power of Mutable Instruments Plaits, the oscillator core. But I wanted to put it in a small, easy-to-solder, battery-powered, standalone thingy. I started discussing this idea with the festival organizers, and we were kind of obsessed with this idea of optical Theremins, using light-dependent resistors, or LDRs, to control the parameters of a synth engine. I wanted to put a bunch of them, not just one or two, but I ended up with 6, although I had prototypes with 10 or 12. 6 was the sweet spot. The goal of the kit was to be inexpensive, easy for beginners, super fun to play around with. I was pretty pleased with what I came up with in the end. Neuztec 2020, sadly, of course, as we all know, was canceled. By the time 2022 rolled around, the global parts shortage just killed any idea of this happening, and it prevented me from building more than a few dozen of these kits, which got in the hands of a lucky few. Now it's 3 years later, 3 years into designing this thing. I'm really ready to share Shadowbox with you guys. There's just a few things you need to build Shadowbox. You need a soldering iron, you need side cutters, a length of solder, and an Allen key or a hex screwdriver to assemble it afterwards. We've written a really nice build guide to walk you through the process. It goes through the absolute beginner steps, how to solder, what a good soldered joint looks like, all the parts, and some information on how it works. You have the actual PCB here, gold plated. This is a wooden back to the Shadowbox with cutouts to allow for the battery holders. There's a baggie of parts here. A sticker. And a little flashlight. We'll put most of this to the side as we start the build. It's best to start with the resistors. You can just pull these off of this little tape here. There's 6 resistors, and they're all the same value. Just need to bend them in, stick them in the little spot, bend the legs out a little bit. and solder them in place. Once your part is soldered, you can go in and clip the excess. So we're just going to do that 5 more times. Start off real easy. Resistors are bipolar or non-polar, depending on how you want to say it. You don't have to put them in either one way or another. Either way works fine. Although it is nice when all the colors point the same way. I'm going to do all of these at the same time. But if this is your first kit, it may be wise to just do one at a time. Again, we're just going to bend these out just so they don't fall out when I flip it over. So a trick I like to say is you put the iron on, you count to 3 in your head, apply a little bit of solder, and then you count to 3 again in your head, and then you pull the iron off. Foolproof way of getting a perfect solder joint. 1, 2, 3, solder. 1, 2, 3, pull away. Okay, our resistors are in place. Next up, we're going to do the LDRs. These are light-dependent resistors. They are resistors whose resistance changes with the presence of light. So you just push them in as far as they go down. And again, just like the other resistors, we bend them out. Got one for pitch, one for timbre, one for morph, one for harmonics, one for the envelope, or the VCA rather, and the model. These are all 6 of the parameters of the Plaits engine that Shadowbox can manipulate. Just like the resistors, I'm going to solder them in place. And just like the resistors, it doesn't matter which way around they go. Oh, all 6 soldered. Can clip these off. Lovely. Next up, we're going to do the power switch up here. Just 5 pins on that one, and make sure you don't flip it around. It'll be difficult to turn off. I like to just solder a few pins and double check my position. Make sure I'm not crooked. If I am, I can just reflow it and readjust. That looks good to me though. Ooh. Have a little bridge there. Just pick it up. Next, I think we'll do the electrolytic capacitors. These capacitors do have a polarity. One side has a stripe, and that indicates a negative. The other side does not have a stripe, and that's the positive. You can also see that one leg is longer. The longer leg is the positive leg. On the PCB, we can see a plus sign indicating positive and a stripe indicating negative. So the long leg is going to go into the hole marked positive, and the short leg is going to go in the other one. There's 2 of these, and they face the same way. Just like that. Flip this over, and while I'm just pushing up on these caps so they sit flush with the board. Ready to clip. The 1/8" output jack for headphones or line out. It's a stereo jack. You can tell because it has 3 conductors, tip, ring, and sleeve. Flip that over and solder in place. Just like the switch, I'm just going to solder 2 points and make sure it's flush before I commit entirely and solder all 6. Next, we're going to solder the brains. This is a condensed version of the core from Mutable Plaits. It has a STM 32-bit processor. That's the big chip here. It has a stereo DAC. That's this part here. It's got some other things that are needed. For example, there's a 8 megahertz crystal oscillator to drive the STM, to clock it. And this part here is actually a step up converter. So no matter what the voltage is coming in from the 2 batteries, 2 AA batteries, which nominally will be about 3 volts, this will step it up to 3.3 volts, which is the voltage that this processor runs on. This step-up converter works down to 0.9 volts, so we should be able to get quite a long battery life out of one of these devices. And in fact, we do. I haven't yet drained a pair of batteries on Shadowbox, but so According to the math, it should be about 10 hours. These little modules I assemble here in my shop, and I've pre-soldered the pins so that I can actually test them before I include them in the kit. So after I built one of these up, I put it in another Shadowbox, made sure it was working correctly, and then it gets the stamp of approval. This goes in the center part here, where it says brains go here, and the two strips of pins are different, so there's no way of getting this backwards. Slot that in like that, hold on to it as we flip. Let me try that again. Hold on to it as we flip. And solder in place. Again, I'm going to do 2 pins only. Confirm my placement. And then I'll keep going with the rest. And there we go. I'm just double checking I haven't bridged any of these pins. That could be quite catastrophic, but it all looks good. The last thing we need to solder are the battery holders. They go on the back where the image of the battery holder is, and you can see that one side has the little spring drawn. That's the negative side of the battery holder, and they both go in the same way around. Just going to bend this one in place a little bit. Just double checking that I'm flush. I can see that this holder is up a little bit. So I'm just going to reheat this pin and push with my finger. I'm going to do that over here as well. This one. Actually, this one's being a little stubborn. One more time. There we go. We're ready to clip these off. These are much stiffer than the resistor legs. Actually, at the workshop, we broke a few of these side cutters with these stubborn battery holder pins. There we have it. The soldering part is done. All that's left is to put the back on. Before you put the back on, you should just double check all your solder joints. You can still touch them up. It's not too late. I think mine all look good. I'm going to put a screw in each corner, followed by a 10mm or 8mm standoff. These are all M3 screws, button head. They require a 2.5 millimeter hex driver or Allen key. I'm just hand threading them for now, and I'll come in and tighten them with the key. You don't have to go crazy on these. They just have to stay in place. Just going to flip it over. Find my wooden panel here. There's some text and some logos on one side. Make sure that those point down. There we go. This one actually has a bit of wood still stuck inside. These wooden panels I laser cut at the Victoria Makerspace, which is a hacker lab that I'm a member of, and I spend a lot of time at. I love being able to just go up there and laser cut weird panels for experimental things that I'm building. These I also stained with some wood stain, just to match the look a little bit better. And there we have it. It's an assembled Shadowbox. The back cover. And you just grab a couple AA batteries. So it was designed to use the batteries themselves as a sort of foot to keep it flat on the table. I think that works quite well. On-off switch, we should see an orange light on the brain come on. And there it is. We know it's working. Time for some testing. Because Mutable Instruments releases all of their modules as open source, meaning we can look at how they're constructed, the schematics, the firmware, the PCB layout, we can extract the core of that module, which is really the processor and the digital to analog converter, and change the interface to something else, whatever we'd like. I didn't want to dive too deep into the firmware. I just wanted to control it in a different way. The usual method of changing parameters on a synthesizer is using a potentiometer. It's a 3-pin device that is actually composed of one resistor going from the outer legs and a wiper that varies the resistance between those. We can draw that out as the schematic diagram with a resistor and a wiper. As we move the potentiometer to the extremes, this wiper moves up and down. If we connect one pin to a voltage, say 3.3 volts, which is typical for digital circuits, and the other pin to ground, we will now have a voltage on the wiper between 0 and 3.3 volts, depending on where on the potentiometer we adjust it to. The concept with Shadowbox is replacing the potentiometers with LDRs. The LDR is a variable resistor that changes with light. If we have our LDR, here, and we add a second stationary resistor that doesn't change, we can connect this one to 3.3 volts, this point to ground, and we can take our output here. Depending on the value of this resistor, we will get some range, not quite from 0 to 3.3 volts, but some sort of usable range. I chose this resistor just by testing. I found that the value that I included there, which I believe is 1K, ended up giving me the greatest control and the greatest extremes, going down to as low as possible and going up to as high as possible. We can actually see this resistor, this resistance change with light by connecting it to a multimeter. With 1K ambient light, going up to 40K, 45K in complete darkness, and reducing down to 1 or 200 ohms with light directly on it. I'll put all these schematics up on my GitHub so you can take a look at them in more detail. But each parameter is a pair of LDR and resistor. Now, the LDR is actually on the top of the wiper going to 3.3 volts and not the bottom like I just drew, because the Mutable Instruments core actually expects an inverted signal, 0 volts being the maximum of that parameter and 3.3 volts being the minimum. This is because the original circuit uses op amps to offset and combine the knob position with the incoming CV that you would get on a 1/8" jack coming in. That op amp circuit has a side effect of inverting the signal, which the firmware then treats inverted to cancel out. We have our 6 LDRs with our 6 resistors. I misspoke earlier, not 1K, 47K for these LDRs. The 2 batteries in series going through the power switch, going to the power. The 100 microfarad capacitors going to 3.3 volts and the incoming battery voltage. On the, what I call the chiclet, is the DAC connected to the pins of the processor, connected to the header, which then goes to the 1/8" jack. We have our simple little boost converter and the processor itself with all its accompanying capacitors, crystal oscillator, an offset voltage, and programming header. You can actually reprogram this if you so choose. I will publish the firmware that I have for this, of course. It has some changes to the firmware just to make a better use of the ranges that we get from the LDRs. But if you'd like to program it yourself, it's a standard, I believe it's the ST-Link connector. It's a 4-pin. Reset, SW clock, SW DIO, and ground. You will need to power it in order to program it. Any case, that's Shadowbox. I hope you like it. All the information I have on it, I'll put up on GitHub. Let me know what you think. Thank you.